Hello all, welcome back to Mechanics. In this video, we are going to learn about some interesting theorem related to forces. Lam has found some interesting and very important relations between forces. To apply Lam's theorem, we should have some conditions like these conditions which should satisfy to apply Lam's theorem. I explain all these conditions using this practical setup of Lam's theorem. The first condition is uh, first, consider this practical setup. Here, the three forces are acting on this rod or rope. This force acts due to the self weight of this, and this force acts due to self weight of this. So kindly ignore this two rods to understand the Lami's principle. Please consider this only. The conditions are first, it should be a coplanar. Here, if you consider with this figure, all the forces acting in this green plane, like consider this xy plane, all the three forces acting in this practical setup is comes under this green plane, that is xy plane. So all the plane acts in the same plane, so it's comes under coplanar. And concurrent means all the force should act on same point. Here the three forces acting on the same point, so it's a concurrent. Say exactly three forces, that is also here. Then equilibrium, consider this object is in stationary, so equilibrium also satisfied. And one more point, that this point is personally derived from me, because the angle between two forces are very important, because consider two force acts like this, the angle between 180 degree. We can convert this force into single force, either in this direction or this direction, based on the magnitude. If in this direction magnitude is high, means we can convert into the force in this direction or this direction based on the magnitude. If the angle between two forces is 0 degree, means it's nothing but a single force, right? Two forces acting in the same line of action means in the same direction, means it's considered as a single force. So what happens if the force between two is more than 180 degree? If consider this is three forces that is acting on one single body, means here that angle between this F1, this F2 is more than 180, and then this object, if you see that all the force is acting on the this direction, so this body is definitely moving in this direction, so there is no way of equilibrium. That's why I derived one a condition for the angle. It should be less than 180 degree and more than 0 degree. So this is a practical example for Lami's theorem. You see the kit on the swing, there is three forces acting. One force is on this, and one force is here, and one force is here due to the self weight of this kit. So kindly eliminate the weight of this, the chair. So we just consider this girl's weight only. So here we have three forces acting in the same point, and it's also concurrent. So this is a practical example for Lami's theorem. And here we can learn what is Lami's theorem here. Consider this three forces that is acting in a same plane, that is coplanar, and it's also a concurrent force because the line of action of the forces meet in the same point, and also it's in a equilibrium, means thus Lam has found something interesting That is, consider this F1, F2, F3. What Lamy has found that the angle between F2 and F3 is considerably affecting this force magnitude, which means that this force is totally depend on this angle between F2 and F3. How the force magnitude is varying means, consider this is a magnitude, force magnitude in Newton, and this is angle means angle between F2 and F3, and this force is magnitude of force F1. This is gradually increasing up to 90 degree, which means if the angle is increased from 1 to 90 degree means the magnitude on this F1 is keep on increasing. So after 90 degree it will start decreasing until it reaches 180 degree. So if the angle become 180 degree means it would come like this until it reaches 180 degree. The forces keep on decreasing. It's more like a sine function. So this is what Lami found that. So he derived these things in a derivation, sorry, in a definition that is mentioned here. When three coplanar concurrent forces acting at a point in equilibrium, this is the conditions. If then each force is proportional to the sine angle of between other two forces. This force is this F1 is directly proportional to the sine angle of other two forces. Consider this is theta 1 and it is theta 3, this is theta 2, means this F1 is directly proportional to sine theta 1, F2 is directly proportional to sine theta 2, this force is directly proportional to the this sine angle, and this force is directly proportional to the other two forces of this sine angle, sine delta 3. So if you put the same constant like F1 sine theta 1 equal to k, the same way F2 sine theta 2 is equal to another constant F3 and sine theta 3 equal to another constant. And if you are making it in one term means F1 sine theta 1 equal to F2 sine theta 2 and F3 sine theta 3. These three terms are equal to constant value. So this is what Lami's theorem about. Lami's theorem has, if you want to apply Lami's theorem, we should have five conditions: coplanar, concurrent, and it should be exactly three forces, and all the forces should be in equilibrium, and the angle between two forces should be less than 180 degree and more than 0 degree. And if all the conditions are satisfied means we can apply Lami's theorem. What is Lami's theorem means that force is proportional to the sine angle between other two forces. So that's what I derive here, that F1 sin theta 1 equal to F2 sin theta 2 equal to F3 sin theta 3 is equal to K. So thank you for your time. Kindly leave your comment in comment box.